Hi everyone, welcome to the 10th session of Matrices and Vectors with Python. In this session, we will learn about the different types of matrices like the row matrix, column matrix, rectangular matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, matrix transpose, null matrix, triangular matrix, symmetric matrix, orthogonal matrix, and singular matrix. Well, from our elementary schooling, most of us might know all of this, what it is, but the main USP of this session will be how to implement or how to generate the matrix using Python numpy. Okay, so let's start. So what is a row matrix? It's called a row matrix if it has only one row. We can see clearly like M is a matrix. For example, it has three elements 10, 20 and 30 and it has only one row and has three columns. If we want to create this in Python, how do we achieve this? So simply we can import this numpy, import numpy, and after that what I will do, we will generate row underscore matrix, which is equal to np.random.random.randint, and after that what I will do, we will generate the element between 0 and 9 and the dimension. What we know, the row matrix, it will have only one row, so one row and how many columns? 5 columns, and then we'll print row matrix. So we will execute and see. So this is a matrix which has 5. Again, if we execute it, it is the numbers are getting generated randomly, so it will be a different matrix. Okay, so now what is a column matrix? So what is a column matrix is similarly like row, but here instead of them one row here, the number of columns in the matrix will be only. So this is the column matrix. We have three elements 10, 20 and 30 in one column, and we have three rows 10, 20 and 30. So how do we execute the column matrix? Simply instead of row we'll give the column. Column matrix is equals to this, and instead of rows we give 5 here, and the rows and column will be swapped. Okay, also here we'll give column. So now you can see we have only one column, but the number of rows is 5. We'll execute this again. Each time the value will be different because we are generating it randomly using the numpy's random function, and the out of random we are using random int. Now what is a rectangular matrix? Rectangular matrix is nothing but if the number of rows is not equals to the number of columns. Here in our example we can see the first example, this one we have 2 rows and 3 columns, but in the second example, this one we have 3 rows and 2 columns. So this is an ideal case for rectangular matrix. How do we generate this in Python? Rectangular matrix is equals to 0, 9, or this time we'll generate between 0 and 5, 6, and what we'll do, we'll give here the dimensions so that this rows and columns is not equal. Okay, we'll execute this. So we can see the rows and columns is not equal. Now we can swap this. We'll give 3 rows and 2 columns. Like, I hope you can understand this what I'm trying. Now after this, what is a square matrix? Now square matrix is if the number of rows is equal to the number of columns, then it is an example of square matrix. We can see here the number of rows is 3 and the number of columns is also 3. So we generate it through Python, and we'll generate between 0 and 9, and what we'll do, we'll give 4 comma 4. So you see we have 4 rows and 4 columns. Again, if we change, every time we change, okay, when we execute, the value will be changed. The thing is what is a diagonal matrix? Well, the matrix is called a diagonal matrix if it at least one element of the principal diagonal element is non-zero and all the other element is 0. Okay, so we can see here the diagonals is 2, 3, 4 and the rest all the item is 0, right? So this is an ideal case for diagonal matrix. Now in Python, how do we implement this? So what we'll say, from numpy import, there is a function in numpy, then we'll generate a matrix first. Matrix is equals to, then we'll print the matrix. We print this. This is a normal matrix. This is not a diagonal matrix. This is just a square matrix where the number of rows is equals to the number of columns. Now we want to create a diagonal. First what we'll do, we'll extract the diagonal of this matrix. So that will be diagonal vector. We'll say this is nothing but a vector, which is diag function, whatever we have imported just now, this diag function, and we'll give the matrix which we have created. So you can see whatever is our diagonal, it is extracted in this diagonal vector. Now what we will do, we'll create a diagonal vector matrix from this vector, from the above vector. So we'll say print, and then we'll give diag, and in that diag we'll pass that diag vector what we have extracted in the previous vector. And now execute this. So we can see 100 cc here, 1071 was the initial diagonal, so this is what, and rest of the element has become 0. So this is an ideal case for diagonal matrix. We will execute this again. From here we'll execute this multiple time. Every time the value will change. Okay, now this is my vector, this 4862 is my diagonal, so 4862 will come here and the rest everything will become 0. So this is the typical case of diagonal matrix. Okay, now the next case is what is a scalar matrix. Now the matrix whose diagonal elements are same and that all the non-diagonal elements are 0 is called the scalar matrix. We can see here 5 5 5 or 2 2 2 or any element in the diagonal. If all the elements of that diagonal will be same, then it's a scalar matrix. So how do we implement this? Simply take an example of a scalar matrix is equals to, now this is not a normal matrix, it is a unit it is nothing but a unit identity matrix into the scalar value. So what we'll do, we'll say any scalar value 5 into an identity matrix is calculated by np.I to give 3 comma 3. When you execute this, you will have 100 like this is nothing but a unit matrix or an identity matrix, and if you multiply this with 5, the scalar value, then you have this matrix whose diagonal elements are same and all the non-diagonal elements are 0, which is, so in this case this is a typical case of scalar matrix. This is the scalar matrix. Now what is an identity matrix? I have just explained here what is an identity matrix, and it is denoted by I. So matrix whose diagonal element is equals to 1 and all the non-diagonal elements are 0, then it is called an identity matrix and it is denoted by I. So if you want to, is equals to this. So if you go open I here, this is like 100010001 is a unit matrix. Even if you want this large 3 by 3, you can make it 2 by 2. So this is my value for the identity. Now what is the matrix transpose? A given matrix M is transformed in such a manner that its rows becomes column and the column become rows, then it is called a matrix transpose. You can see here 240, after the transformation it has become 240. 319 has become the row, second row has become the second column, and the third row has become the third column, and this is a case of matrix transpose. How do we achieve this? So first of all, I will take a normal matrix. In order to get the transpose of that matrix, we have to simply give matrix dot t. Okay, so this is my normal matrix, and if we give the transpose, so you can see 1830 has become the row here, this is column here, and it has become row. Now 3062 has become, this is a column here in the first matrix, but after transpose this has become the row. Similarly for the other rows. What's a null matrix? Now a matrix is called a null matrix if all of its elements are 0 and it is denoted by O. So suppose we have, like, this is a null example of a null matrix. Now if you want to execute this, if you want to print the null matrix, so what we'll do, we'll just create np.empty and we'll give the dimensions and then we'll print it. So you can see this is an example of a null matrix. Now after this, what we have, the next item is a triangular matrix. What is a triangular matrix? A triangular matrix is a type of square matrix that has all the values in the upper right or the lower left of the matrix, with the remaining element filled with 0 values. If you see this element here, this is a lower triangle, and again for this other matrix you can see this upper is a upper triangular matrix and it's a lower triangular matrix. And if you want to execute this in Python, how do we get this? So it is very simple. In Python numpy there are a few functions, we will use that. So what we will do, we'll give from numpy import, see this is tri triangular L for lower and tri triangular U for upper. These are the two functions we'll use, and we'll normally create our own matrix. So this is our matrix. Now we want to create a lower triangular matrix. Lower is equals to, this is nothing but here if you can see this element here, right, this is an example of lower triangular matrix. This is exact. Okay, if you see this value 1442, this is last three elements 0 0 00 followed by 30. They are a typical case of the lower triangular matrix. Now what we can do, again the upper triangular, then print upper. You execute this. Now you can see here this is very good example of upper triangle. So this is how we create the upper and lower triangle, and this is how we learn how to identify a lower triangle or an upper triangular. Now we'll check what is a symmetric matrix next, I suppose. Yeah, symmetric matrix. What's a symmetric matrix? A symmetric matrix is a type of square matrix where the top right triangle is same as the bottom left triangle, or in other words, symmetric matrix is a square matrix which is equals to its transpose. So as usual, we'll create our matrix. We will create our matrix. This our normal matrix is created. After that, what we'll do, we'll create a matrix transpose. Okay, so we can see here 7254 has, it is row here, but it has become the column here. Okay, but intention of this specific code is not to create the transpose, is to create the symmetric matrix. So what we'll do now, how to generate the symmetric matrix is equals to matrix plus underscore transpose. We will add both this. So if we add these two, the diagonal elements will be added twice. So minus, so what we'll do first, we will execute this. The diagonal element is extracted if we execute this part only. So we have created a matrix with only diagonals. Okay, rest element everything is 0. After that, we will add both these values. The matrix is added with its transpose, and from that what we'll do, we will subtract the diagonal value. So now you can see this is a symmetric matrix because the rows and the columns are exactly same. If you transpose that, you will still get this value only. So this is example of symmetric matrix. If you are really interested to write if you are really interested to check how to, instead of using this tricks, how to write it using for loop, please ping me, else you can write a code and paste in the chat. So that is for the session. If you feel this video is helpful, please press the like button and subscribe to this channel. Please note you can contact me at technologycult@gmail.com, and the link for my GitHub account is github.com https://github.com/technologycult. And thank you.